So I will start by sharing my screen here. Okay, so welcome everyone. Thank you for joining us tonight on a very cold evening in Edmonton. And if you're not from Edmonton, thank you for making the trip virtually. This is what's up over Edmonton for the month of February 2020. We always start off with a picture of the Queen Elizabeth Planetarium, where we initially planned to do these sessions from, but COVID got in the way, so we do this online. We eventually plan to be back at the QEP doing this live in person. And I can't forget today is Groundhog Day. There he is, popping up. And I don't know how he made it out in Puxatawney, Pennsylvania, but here in Edmonton, the sun was shining. He saw a shadow, so I guess that means 6 more weeks of winter. But I understand if he didn't see a shadow, it still means 6 more weeks of winter. So yeah, whatever. We call it What's Up Over Edmonton because our sky sitting here at 53 degrees north latitude is definitely different than the skies is portrayed in a lot of astronomy magazines and such. For example, here is the sky over Toronto at 11 o'clock on July the 5th. And I always point to this constellation here, Scorpio. Because it's a fairly big constellation and it's a constellation that actually looks like what it's supposed to be, a scorpion. As you can note, the whole constellation is above the horizon. This is the sky over Edmonton on July the 5th, 11 o'clock. Well, we're in perpetual twilight, so the sky never gets dark, but you'll note that Scorpio does not get above the horizon. You never see his tail or his stinger. And this is the most of Scorpio you'll ever see from Edmonton. Even if you went down to the border with the United States, you still wouldn't see the entire constellation. So hence, what's up over Edmonton? Most of the information I use comes out of the Observer's Handbook. It's a great resource of astronomy information. It's 352 pages packed full of everything you could possibly want to know as an amateur observer. This year there's 3 significant revisions to the handbook and 6 new content sections. So sky in February, the groundhog says what? Sunrise today was at 8:17. It's set at 5:18, and astronomical twilight ended. That is, night began proper at 7:18 tonight. On February 28th, the sun will rise at 7:23. It will set at 6:10. And night will begin at 8:06. So what do we got for some highlights? We got the last chance to see Jupiter before it leaves the evening sky. If you went out right now, it'd be gone. It would already have set. It's the best time of the year to view Orion and its nebula, and I'll talk about that a little later. And Venus is very bright in the morning sky. I can wake up before the sun comes up, look out my bedroom window, and there it is, blazing away. And Mars is low in the southeast before dawn. I haven't seen it yet because it's generally been on clear mornings. It's been too bloody cold to go out and get away from the houses across the street to view it, but it is there. So this is the planetarium portion, and as always, I have pre-recorded this. So we'll start that. Okay, we're going to start looking at what's in the sky over Edmonton for the month of February, and I've started on February 3rd, tomorrow at 6:30. Now the sun has set just over an hour before, and the sky is still lit up slightly, but I did this just to show that Jupiter is very low in the southwest, west-southwest, less than 10 degrees above the horizon at 6:30, and it's our last chance to see Jupiter or any naked eye planet in the evening sky for the next little bit. Now you may have noticed, certainly I have, a few months ago in December, Jupiter would have been setting about here, but it is steadily moving west as the ecliptic, which is this line here, the line in which the sun, the moon, and the planets travel, moves west, and by June the ecliptic will bottom out in the west-northwest. Now, if we follow Jupiter through the month, you can see that every day at the same time, Jupiter is lower and lower and lower. And by the end of the month, Jupiter is nowhere to be seen at 6:30. And of course, the sun is setting later and later, and the sky is getting lighter. Moving on, changing the time to 7:30, when the sky now on February 3rd is completely dark. We see the moon low in the southwest, a 3-day-old crescent moon, near Neptune. So if you have a telescope or a steadily held pair of good binoculars, you can use the moon to locate Neptune and have a look, and you will know Neptune because it has a bit of a bluish tinge to it. And here's a close-up, and let's see here if I can draw my line. There we go. You can see that Neptune and the moon are about 4 degrees apart. That's the diameter of 8 full moons. A full moon is half a degree in diameter, approximately, and so if you find the moon and then look to the right and slightly up, you should be able to spot Neptune fairly easily. And the only other planet that is in the evening sky is Uranus in Aries. This is Aries here. It's Aries the ram that looks more to me like I don't know, field hockey stick. But anywho, there's Uranus, and there's also the dwarf planet Ceres, which, as I've mentioned many times before, was the very first object found in the main asteroid belt between Jupiter and Mars. Now, before I leave the evening sky on February 3rd, assuming it's clear out, and we haven't had very many clear days lately, there's an opportunity to see the International Space Station. We've had a pretty good run of ISS sightings for the last couple weeks or so, and the window to see the ISS in the evening sky is ending this week, but just run this. This is running 30 times faster than normal speed. The crossing actually is going to take about 6 minutes, and there's the ISS there. You can see it peaks at about 30 degrees, and then disappears into the southeast sky. So, like I say, if it's clear tomorrow, go out, have a look at the ISS. It'll be very bright, very visible. Uh, it can get as bright as Venus sometimes, certainly as bright as Jupiter.
And I forgot to mention the time, which is
For
at
naked eye
6:02.
planets, you have to go into the morning sky to see them. And so I've set the time at 7:15 for tomorrow morning, and so about an hour before sunrise. And in the twilight sky, Venus will be visible, looking very much like an airplane landing light in the southeast, and below it is Mars, shining quite a bit dimmer. If we advance through the month, Venus gets higher and higher at that same time as 7:15, and Mars is climbing too. And here comes the moon. And by the end of the month, right on the horizon, is Saturn and Mercury. Now, unfortunately, as you will note, the ecliptic is very low in the morning sky this time of year, about as low as it's gonna get. It kind of echoes where the ecliptic was back in the fall, in the evening sky when it was extremely low. So, but Venus and Mars should be, well, Venus will be extremely easy to spot. Mars, you'll be able to see also. You might need a pair of binoculars to cut through the twilight sky. Some highlights involving the planets in the morning sky, if you have read about them in either the Observer's Handbook or one of the astronomy magazines that you can pick up at any newsstand. On the 12th, for example, Venus is at its greatest brilliance. It shines at magnitude minus 4.5, which is extremely bright. Venus reaches its greatest brilliance not when it is closest to the Earth. When it's at its closest, you can't see it because it's in the same line as the sun. But as it either approaches the sun in the evening sky or moves away from the sun in the morning sky, it goes through a crescent phase. And if you have a telescope and looked at Venus, you would see it's a crescent getting a little bit fatter, the sun shining off the cloud tops of Venus, which is why Venus is so bright, because it's completely covered in clouds. You would see a crescent Venus. And another thing you might read about in an astronomy magazine or in the Observer's Handbook is that on the 16th of February, Mercury is at its greatest eastern or western elongation, the highest point it will get in the sky above the sun for this cycle of its orbit. Now, again, I have the clock set at 7:15 in the morning, and where's Mercury? Well, Mercury is right about here, and because I use this Arctic hellscape that we're living in right now, it is just behind this little ridge. So if I make the scene disappear, this is the horizon right here, and Mercury, because of the low ecliptic in our latitude at this time of year, Mercury is less than 2 degrees above the horizon, just about 2 degrees above the horizon at 7:15 in the morning on the 16th, when it reaches its greatest western elongation. There's the sun, and it's 26 degrees away. If the ecliptic was at a high angle, as it will be later on in the year in the morning sky, Mercury would be easy to see. And we've talked about that in earlier episodes, and I've shown some pictures that I've taken of Mercury in the morning sky. But for us in Edmonton, unless you have a absolute clear horizon with no buildings in the way, no clouds along the horizon, you're not going to see Mercury this time around, because as we advance through the month, Mercury gets lower and lower as it moves closer and closer to the sun, and now we're into March. On the 26th, there's an opportunity to catch a lopsided triangle of Venus, Mars, and the Moon low in the east-southeast, which would make a fine photograph if you have a good viewing spot. On the night of the 8th, this might be something you might want to have a look at. It is the moon closing in on the dwarf planet Ceres. I bring this up because if you happen to be living on the other side of the world, in the Indian subcontinent and such, the moon will actually occult or pass in front of Ceres. But through the night, on the night of the 8th, you can actually see the moon moving, getting closer and closer to Ceres. And this is going at 300 times normal speed. Ceres is about 4 degrees below the Pleiades here. And as you can see, it is the moon is, as it makes its way around the Earth, is moving towards Ceres. Occultations are of the moon in front of stars and such are really neat to see. I've seen a few of them, and I always like watching the moon occult a star, because the star just doesn't fade away; it just winks out as the moon passes in front of it. And you can watch it till about 2 in the morning, after which the moon sets, and there we go there. And let's look at the night sky in February over Edmonton. Looking south, of course, we have the bright stars of what is informally known as the winter circle, which is Capella, Aldebaran, Rigel, Sirius, Procyon, and Pollux. So that's the winter circle, all very bright stars visible in the winter sky. The most dominant constellation in the winter sky is Orion, right here, Orion the Hunter. We've talked about him before, with his 3 belt stars, which you can use to point to the Pleiades. And going the other way, it points down to Sirius, which is the brightest star in the night sky seen anywhere on Earth. Of course, we can't leave Orion without talking about the Orion Nebula, one of amateur astronomers' favorite objects to look at and photograph. So, of course, there's Orion, there's his shoulders, his knees, and his belt, 3 belt stars in a line. And if you look below the center star of the belt, you would see a line of stars here, which is referred to as the sword of Orion. And if you have very good eyes and looked at it, you might notice that one of the stars in the sword is a bit on the fuzzy side. And if you looked in binoculars, you would see that, oh, it is kind of fuzzy. And if you looked closer with a telescope, you would see there is a cloud of gas and dust. Now, to the naked eye, it's not going to be all colorful like this representation here. It's going to look kind of gray, maybe a hint of green. But this is the Orion Nebula. This is the closest star-forming region to Earth. And if we can get this to, well, this program doesn't seem to want me to zoom in anymore or move about. But in a telescope, if you looked at the center of this cloud, you would see these 4 stars, which is called the trapezium. And these stars are newborn stars, probably less than 1 million years old, maybe even only 100,000 years old. And they were born in that cloud, and their ultraviolet radiation has punched a hole in the cloud so that we can see them. But they're what's lighting up the Orion Nebula. Now, infrared telescopes, which can see past the dust, make the dust transparent, show dozens and dozens of stars within that cloud being born. So anyway, the Orion Nebula, it's a cool thing to see. And we also have Taurus. Whoops, flipped it the wrong way here. Directly above Orion. And one of the myths I think we talked about last month, Orion is constantly chasing Taurus the bull across the sky. We also have Aries here, which I talked about earlier. Doesn't look like a ram to me, but hey, what are you gonna do, right? Also, we have some of the spring constellations coming up now. Here's Leo the Lion with its bright star Regulus. We're starting to see Bootes the Hunter, which contains the bright star Aldebaran, but it's still below the horizon here at this time of night. The time of night I've set here is 9 o'clock. If we shift around into the north, the Big Dipper, which was very low a few months ago, is climbing higher and higher into the sky at this same time, and in another month or two it'll be almost directly overhead. There are constellations that never set in our part of the sky, such as Cassiopeia and Perseus. And what else we got? Draco the Dragon, snaking its way across the sky. Its head is quite low in the north at this time of year, with Ursa Minor or the Little Dipper directly above it. And of course, if you're lucky enough to live in a rural area or get away from the city lights, you can see on a moonless night the Milky Way arching across the sky from the southeast to the northwest. Anyway, with that, that closes the planetarium portion of the program. Okay, I'm going to have to work on something, because I noticed it cut off the right-hand side of the screen. It looked perfectly well when I was running this a bit earlier in the day, but on Zoom, yeah, have to fix that. Anyway, are there any questions? No? Alistair, do you have anything to add?
No, that covered everything. Hit the International Space Station as well. Like I was going to say the same thing. We're still got some nice passes, but we're running out for the evening.
And as I yelled in there when I was listening to that, oh my gosh, I forgot to tell you what time it was. It was 6:02 is when it comes over the horizon tomorrow. Hopefully we'll have a clear night. Okay, we'll move on to the next section.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon?
Okay, the moon was new yesterday, February 1st, also the start of the Lunar New Year, for those people who celebrate it. And I put an asterisk beside it because actually, because this is what's up over Edmonton, the moon was not new on the 1st, it was new on the 31st of January. It was new in an exact line with the sun and the earth at 10:46 p.m. on January 1st. But calendars are based on either Eastern time or Universal time. So in those time zones, it was February 1st. So first quarter is on February the 8th. The moon is full on the 16th. And the February full moon is known as the snow moon. It's obvious reasons for that. Other names are the hunger moon, because food is so scarce at this time of year, or the storm moon. And I understand we're getting one this weekend again. And then last quarter is on February 23rd. I always like to take a page from the RESC Canada Explore the Moon Certificate Program for an object on the moon to highlight. There's two programs, certificate programs, one for binoculars and one for telescopes. And so the object we're going to talk about today is the crater Suchard. Unfortunately, I don't have a real good picture of it. This is a picture of the full moon I took a while back. And the crater is right there. It's right along the edge of the moon. And it's seen 12 days after new moon, and then in the days following as the sun crosses in front of it. It's a large circular crater, although you wouldn't know it from this picture, but it appears oblong because of where it sits on the lunar limb, and foreshortening gives it the elongated appearance. It was named after Wilhelm Suchard, a 17th century scientist who was also a friend of Johannes Kepler, the man who came up with the laws of planetary motion. Suchard was no slouch himself. He was very much a jack of all trades scientist, studied all sorts of things, and he also designed mechanical calculating machines for mathematics and astronomy. Now, you may notice in this picture, I've got a better picture further on here, that there's areas of light and dark. It's the floor is light in the middle and dark on the edges here. Here, I'll go back again. You may notice in this my picture here, you can see this dark area the top, and then this dark area here and a light area in the middle. And that's because the crater was only partially flooded with lava, and that's what gives it its textured look. As you can see in this picture, taken from Earth, obviously, because it is oblong in this view, but it's actually a circular crater. It's 227 kilometers across, so it's quite a big one, and it's about 1.5 kilometers deep. And there's another view from Earth. You can see the darkness in the two areas and where the lava has flown into the crater, and also has a number of secondary impacts after the initial crater was formed. And this is a picture taken from straight overhead by one of the lunar orbiters. And you see it is indeed a circular crater. It's an old crater, as you can tell by the erosion of the wall and the impacts in the wall. But you can clearly see the two areas of lava flow. I always like to pick a constellation, and the constellation I'm picking is Canis Major, or the Greater Dog, right about here. There's an astronomical view of it, looking somewhat dog-like. And there is the dog. It's known as Orion's hunting dog companion, and he follows Orion faithfully through the sky. Now, there's two features in the constellation I'd like to point out. The first one is the most obvious, and this is Sirius, the bright star, which I mentioned in the planetarium portion. It's also known as the dog star because it is part of the Greater Dog constellation. It has a lot of legend attached to it. It's rising right before the sun in the summer months marked the coming of the Nile floods for the Egyptians. For the Greeks, it meant the coming of hot, dry summers. Its name, Sirius, derives from the Greek meaning scorched. Also, it's where the term the dog days of summer comes from, because it relates to this star rising just before the sun in the summer months. Now, because it rides so low in the horizon, particularly in our part of the world, if the air is unsettled, it'll appear to dazzle. Oh, here's a picture of the star. Anyway, as I say, it appears to dazzle, and I'm sure if any of you have looked at Sirius and seen it in this kaleidoscope of color, and it is not the star doing the disco ball imitation. It's our atmosphere, and this very, very bright star being low on the horizon with unsettled air, and you get all sorts of effects of refraction and such, and the star will change color. And this is a photo that someone in England, and England is roughly the same latitude as we are, took of Sirius as it traveled across the sky over a period of time, and you can see this rainbow effect caused by our atmosphere. When the air is steady, it glows a bright white. I'm reminded that last Saturday night, my wife and I were out in the backyard at night, because it was a nice night and it was clear, sort of. And she asked me, "What planet is that?" And it was around 10 o'clock. And I said, "Well, no, there's no planets." And so, "Well, what's that then?" And I said, "Oh, that's Sirius." It's, and I explained it's the bright star, brightest star that we can see from Earth. But the air was unusually calm that night because it shone with a steady white glow. Sirius also has a companion star. This is an image from Hubble, and there's Sirius there. And it has a little white dwarf companion star, which is known as the Pup. The Pup orbits Sirius every 50 years. And its distance from the planet varies quite a bit. And right about now is a good time to see the Pup. It is very difficult to see with the bright star kind of overwhelming everything. I've never seen it. I've tried, but I've never seen it. But I will still give it a try. The next object in Canis Major is the open star cluster M41, also bears the name NGC 2287, and it is also known as the Little Beehive, and it is about 4 degrees below Sirius right here. And so here's a finder chart, Sirius Messier M41. Charles Messier was a comet hunter, a French comet hunter, and he came up with 110 objects that he looked for comets, but when he saw something fuzzy in the sky, which is what comets look like until they developed their tails, he wanted to make a list of all these objects so people wouldn't mistake these fuzzy objects for comets. So this is M41. The Orion Nebula, which I talked about earlier, is known as M42. So he charted M42 and the Orion Nebula right after this one. So it's an open star cluster, as I said, and it's about 4,300 light years from Earth. It's quite small. It's about the size of a full moon, and covers there's about 100 stars in it, including several red giants and some white dwarfs. It's about 25 light years across, and you really need a telescope to see it. In a good pair of binoculars, you might see a fuzzy ball, but a telescope really is needed to make this guy out. And here's a better picture, and you can see some of the red giant stars mixed in amongst the cluster. Now, I can't leave Canis Major without talking about Canis Minor, the lesser dog. And there it is. And I don't know what people were thinking when they saw this as a dog, because to me it looks more like a stick a dog would play with. But anyway, it accompanies Orion off to his left. And that's all I'm going to say about the lesser dog. So other highlights, Venus is at its maximum brightness in the morning sky on the 12th. As I mentioned, Mercury is at its greatest eastern elongation on the 16th, but it's really, really, really low in our sky. The waning moon joins Venus and Mars on the 26th, and it's hanging around on the 27th. But again, because the ecliptic is so low, on the 27th, the moon is going to be really, really low. It may not even be able to see it. And look for the zodiacal light after in the evening sky after the 18th for about 2 weeks until the moon enters the evening sky again. And the zodiacal light is light from dust left over from the formation of the solar system. In the fall, it is visible in the morning sky, and in the springtime, it's visible. In the evening sky, you need to get out of the city to a very dark site to see it, and it'll look like a pyramid of light coming up out of the horizon, above of where the area where the sun went down. Oh, if you see a couple chats here.
Yeah, Jeff, yeah, some really good questions from Linda. I mean, actually, if you allow me to screen share, I'll tackle the first one while you think about the answers for the next two.
Okay, let me look at them here.
I think I can just...
Where does the space station go when not seen?
Yeah, so I've got, here we go, heavens above. So what ends up happening is that the space station orbit is essentially, give or take, it doesn't change. It just keeps in a circle going from, in this case, lower left to upper right, disappearing around the back side and coming around again. And then the Earth just rotates underneath it. And so it just so happens, like you'll see, well, we in Edmonton are just in the dark side. So when the space station happens to be orbiting so that we are in the dark and it's still in sunlight high up, we get to see it. But say the folks right now in Japan, for them, the ISS passes during the day. So it's still there and it passes by, but you just can't see it because the sky is too bright. And so one of the really neat tools that we use here to do this is it's completely free, heavensabove.com. You can sign in anonymously, but when I sign in with a name and password, it remembers my home base, and you can have several home bases actually. And then right here, it says 10-day predictions for the ISS. You click on that somewhere, and okay, now care about ads being removed. That was nice. Let's try this again. Hello. Boy. It's not wanted. I'm trying to click. Oh, sorry about that. When you do click on this thing and it works, oh, that must be something bizarre going on. Or maybe the page is in the middle of loading. Let's try this. Come on. There we go. It produces a whole bunch of what are called passes. And so as you can see here, the evening passes are ending very shortly. And if I just click on for the next 10 days, it will go and bring me the next set. And then these are becoming the morning passes. And so it then becomes visible after almost 2 weeks of doing all its passes during the day. It then occurs in the morning sky, and then we'll get a full set in the morning. Some of them being way too early and others being semi-reasonable time, 6 a.m. So if you're out walking the dog, you can get some very nice passes. But this is a great tool, and if you just click on one of these ones, you get a sky chart, and it'll show you where in the sky it passes and at what time every minute it goes by. So it's a really great way of tracking the satellite. And with that, I will stop sharing and we'll go back to Jeff.
Okay. Yeah, and I don't know if you noticed on that chart that Alistair showed, the space station's path just kind of appeared in the middle of the map. That's because that is when the sunlight is starting to hit it. So it'll just sort of show up, and because it's a morning pass, it'll be illuminated all the way down to the horizon. In the evening, if the sun is low enough on the horizon, you'll see it as it comes up over the horizon, then it'll just vanish. And that's because it's gone into the Earth's shadow. So, alrighty, let's go back here.
So the first question was, or next question is, does the moon still have lava flowing?
As far as we know, it doesn't. There, you know, we've seen changes on the moon coming from impacts and from rocks rolling down crater walls. This is taken from the Lunar Reconnaissance Orbiter, which has been in orbit around the moon for quite a while now, and it's mapped the whole moon, you know, several times, and they have recorded changes. But as far as lava flowing, no. It's appears to be dead as far as that goes. It doesn't have enough internal heat for lava to flow. If a really big rock hit it, it would make lava, but as far as making its own, no. The moon is doesn't have any more active volcanoes on it or anything.
And they figured things stopped about 3 billion years ago. So it's been frozen for a long time.
Yeah, yeah. Okay. Okay, this is the part of space history where we talk about something that happened whose anniversary is anniversary year is divisible by 5 from this year. So we will, in 2022, we will look at years that end in 2 or in 7. We're going to go back 55 years to February 20th, 1962. And this was the day that John Glenn became the first American to orbit the Earth. And he flew in a one-man Mercury spacecraft, which he christened Friendship 7. And this is the launch of Friendship 7 aboard an Atlas booster. There's the capsule at the top, launch escape system, and this is just an adapter to mate it onto the booster. There's a picture of Glenn with the name of the spacecraft written on the side, Friendship 7. The Mercury Capsule was America's first spacecraft. It was the first manned program, and the Mercury program was conceived as a response to the Russian launch of Sputnik 1, which shook up the Americans and the entire Western world quite a bit. But the Russians, who were considered to be backward peasants who had trouble developing a tractor, managed to put the first satellite into orbit. So they came up with the Mercury program to put a man in space soonest. They were going to beat the Russians because they knew the Russians were working on the same goal. The Russians, of course, beat the Americans into space. Yuri Gagarin became the first man in space on April 12, 1961. The Americans followed with Alan Shepard with a suborbital flight on May 5th, 61. And then Gus Grissom flew on July 20th, I believe, 61, another suborbital flight. But by the time February 20th rolled around, the Russians had had flown 2 orbital craft. Gagarin's flight was only 1 orbit, but German Titov in Vostok 2 was in orbit for a whole day. So the Mercury capsule was very small. It was 3.3 meters tall, tip to base here, and 1.8 meters across, or about 6 feet. And it weighed about 1,400 kilograms, or about 3,000 pounds. With the launch escape tower, which isn't shown in this picture, it was 7.9 meters tall. The inside of the capsule was very, very cramped. Like I'm a big guy. I'm 6'4". I would never fit in this. I would never be an astronaut in Mercury days because anyone over 6 feet was disqualified because they wouldn't fit in this thing. It was very, very small. It was only 2.8 cubic meters of habitable space. And the joke about the Mercury capsule was you didn't so much get in it as put it on. At the back of the capsule is the retro rocket pack. It was a package of 3 solid rockets used to deorbit. The retro pack was held on by these straps. And there were also what we called the posigrade rockets, and these were used to separate the capsule from the booster once the booster's job was finished. Now it was called Friendship 7. All the astronauts' spacecraft that flew in the Mercury program had the letter 7, or number 7 in the name. Shepard's was Freedom 7, Grissom was Liberty Bell 7, Glenn was Friendship 7, Carpenter was Aurora 7, Schirra was Sigma 7, and Gordon Cooper, who was the last of the Mercury astronauts to fly, was Face 7. You say that's only 6. So that's because one of the astronauts, Deke Slayton, or Donald Slayton, developed a heart murmur and he was grounded. He became, this is Slayton right here. They made him head astronaut. He ran the astronaut office. Now, if you've read anything about the history around the Mercury program, or read the book The Right Stuff, or seen the movie, you'll know these guys, as soon as they were picked, these 7 test pilots who became astronauts became national heroes. You know, they were famous. Everybody knew their name. Life magazine signed an exclusive contract to get their stories, which paid them quite well, which supplemented their regular military pay, because that's all they got was regular military pay. So they had this lucrative contract, and to give their exclusive stories to Life magazine, and people just ate it up. They couldn't get enough of the astronauts. They want to know everything about them. They want to know all about the astronauts' wives too. They sent photographers around to photograph their day-to-day life and their training and what it was like at home. And they were given free cars and housing. They had a free lunch anywhere they went. The public just couldn't get enough of these guys. After Shepard and Grissom's flight, John Glenn was the next guy up in the flight line. And he was going to get the first orbital flight. And as I already mentioned, the Soviets had already made 2 orbital flights. President Kennedy had set a goal in '61 to land on the moon by the end of the decade. So there was a lot riding on this flight. The mission was 3 orbits. It was almost 5 hours long. The Atlas booster, which put Glenn's capsule into a 150 by 248 kilometer orbit, which by today's standards seems pretty low. And the thinking of this low orbit was, if the retro rocket package on the back here didn't work, the orbit would naturally decay before provisions ran out. The Russians did the same thing with Yuri Gagarin's flight. The Mercury capsule being a lot smaller and a lot more limited in endurance than Vostok. Vostok had enough provisions for 10 days because that's how long it would take for its orbit to decay. Mercury couldn't carry that amount of provisions. It was a much smaller spacecraft. And you will note, if you ever listen to any of the air to ground, when he gets into orbit, they say you're good, go for at least 7 orbits. It means you are in orbit for at least, if your retro rocket fails, you're in orbit for at least 7 orbits before your orbit begins to decay. Glenn was monitored throughout the flight with biosensors, and they were also watching him. They had a movie camera, which they would examine after the flight, watching Glenn throughout the flight to see what he was doing. And they also had another camera back here, and it was watching the instrument panel to see what switches he was flicking and what the instruments were reading. And also he had a mirror down here on his chest, and it doubled as a reflector in case he was came down somewhere other than the recovery area. He could use that as a signal. But it also, when they would look at the movie film after, they could also see the controls. And there was a clock back here, so the movie looking at him would know how far they were through the mission. Now, one thing they didn't really think about before the flight was, we should take some pictures while we're up there. The astronauts didn't take 80 pictures on the suborbital flights because they were only 15 minutes and they didn't really have the time. But Glenn was going to be up there for almost 5 hours. So Glenn said, why don't we take some pictures? Oh, well, we didn't really think about that. So Glenn went to a local Woolworths and bought a Minolta automatic camera with a fixed focus that he could take pictures out the window. And that's another picture here. We can see a landmass here. I don't know what that landmass is, but he did take some pictures. Now, during the flight, when he was going into near orbital sunrise and sunset, he reported seeing what he called fireflies outside his window. And what this later turned out to be was flecks of ice that came off the control jets. The control jets used hydrogen peroxide and fired against a catalyst. Now, not the hydrogen peroxide you find in your medicine cabinet. This is highly concentrated stuff, and I was in the valve business for 40 years, and concentrated hydrogen peroxide can be very nasty stuff. But when they fired the control jets, it produced little ice crystals, and they would float around outside the capsule, and with the low sun angle at sunrise and sunset, they became visible, and they called them Glenn's fireflies. Now I've got a little movie here of watching Glenn. This is right at just as the booster burns out and he goes into orbit. So I will ask you, watch this little flap on his harness there as he enters orbit.
All systems are go.
Roger, 20 seconds to go.
Roger. Indicating 6 Gs. Say again.
That still looks good.
Roger. Seco. Positive grades fired. Okay.
Roger, 10.
Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous.
Roger, turn around has started.
Roger, capsule turning around, and I could see the booster during turnaround just a couple of 100 yards behind me. It was beautiful.
Roger, 7. You have a go, at least 7 orbits.
Roger, understand go for at least 7 orbits. This is Friendship 7. Can see clear back a big cloud pattern way back across toward the Cape. Beautiful sight.
Oh, in case you're wondering, SECO means single engine cutoff. And, he mentioned he was pulling 6 Gs right at the end of the burn of the booster. And then when he was in 0G, you could see the little flap on his harness start floating around. The flight was by the book until the end of the second orbit, when an indicator at mission control indicated the landing bag is deployed. Now, what is a landing bag? This is a picture of an earlier Mercury capsule. You can tell because it has portholes, not a window, being hauled up after a flight. And this thing on the bottom here is the landing bag. And it deploys after the parachute comes out. And it's designed to cushion the spacecraft when it hits the water. At the bottom of the landing bag is the heat shield. So an indication that the landing bag is deployed is not a good thing when you're still in space, because it means the heat shield has come loose from the spacecraft. So it now Glenn didn't have any indication in his spacecraft that the landing bag had deployed, and he didn't hear anything because when the landing bag is deployed, there's a bit of a thunk, but he didn't hear anything and feel anything. His instrument said everything was tickety-boo. But they decided, just in case, to keep the heat shield attached, or keep the retro pack attached to the spacecraft through reentry. Now, normally after the retro is fired, they jettison this pack, and it was just held on by these three metal straps. So they entered the atmosphere with the retro pack still attached, and Glenn reported seeing chunks of the retro pack and strap flying past his window as it re-entered the atmosphere. And it turned out that the landing bag had not deployed after all. It was an instrumentation problem at mission control. Glenn's flight was a huge success, and it was front page news across the Western world. Glenn was met by President Kennedy. Oh, you can see how the heat of reentry has faded the Friendship 7 painting on the side of the spacecraft. And there's Kennedy looking inside the spacecraft, and he's saying, well, and I thought a PT boat was small. Wow. With Glenn next to him. There were ticker tape parades all over the country. Babies were named after him. Schools were named after him. Songs were written about him. I mean, he was a celebrity of the first order. But he never flew in space again because, like Gagarin, he was thought too valuable as a symbol to risk on another space flight. So he left NASA in the middle 60s and went into some business ventures, and later got into politics. And he was elected a senator for Ohio in 1974, and he held that position until he retired in 1999. He actually ran for president in 1984, but lost the nomination to Walter Mondale. In 1995, after reading a book on space physiology, he realized many of the changes that occur to astronauts during long space flights, such as bone loss, muscle mass, and blood plasma, are the same changes that occur due to aging. And so Glenn thought NASA should send an older person on a shuttle mission and basically be a guinea pig. And he thought the person they should send was him. So after studying the proposal and testing Glenn to see if he was fit for flight, NASA agreed, and on October 28th, 1998, STS-95 lifted off with the 77-year-old John Glenn. Life put out a special issue with a cover that was somewhat reminiscent of the cover they put out back in 1962 with his face on the cover. Now, at 77, Glenn is still the oldest person to orbit the Earth. This is a mission patch for STS-95 with the Mercury 7-7, the shuttle, and then a Mercury capsule circling the shuttle and with the names of the crew. Glenn passed away, even though he was the oldest of the Mercury 7 astronauts. He was the last to pass away in December 2016 at the age of 95. Now, just put a little side note here. As I mentioned, the Mercury 7 were instant heroes. Now, when I was a kid, I was a big fan of the Thunderbirds. Jerry and Sylvia Anderson's Super Marionation puppet show set in the not too distant future. And the names of the pilots, Alan, Virgil, John, Scott, and Gordon, they took those names from the first names of the Mercury astronauts. Now, if there were only 5 Thunderbirds, if there were 7, I'm sure there would have been a Walter and a Donald. And their dad, Jeff Tracy, was the father of these boys, and I'm sure he was named after me. And one other bit of a side note, in the 1990s, Hallmark put out a series of space-themed ornaments. There were 4 of them. There was a rocket, there was this Mercury capsule, there was a lunar module, and then there was a lunar rover. And they plug into the mini lights on the tree. And of course, I have all 4 of them on my tree, and they are proudly put on the tree every year. And when you turn the tree on, they get the power through the mini light socket, and they light up and they talk. So Christmas at our house, when you turn on our tree, is this. Whoops. Okay, the last thing here is a old CBS launch with Uncle Walter Cronkite, and I've got a little treat at the end here, and you may note how steady the cameraman of the day tracked the rocket in flight.
We'll be standing by for that announcement.
Mercury Control, the MA6 launch countdown is at T-minus 5 minutes and counting. T-minus 5 minutes and counting. Mercury Control.
Don't worry, it's not
The
5
last
minutes.
5 minutes of this countdown is on. All conditions go. 15,000 persons in the recovery forces standing by. Another 500 in the tracking forces standing by. A press corps of 500. And we of television and radio standing by. And atop that rocket, Colonel John Glenn standing by. It's a few seconds late. It's 20 seconds now.
The Mercury spacecraft
15.
umbilical is out. We're at T-minus 19 seconds. T-minus 10 seconds counting. 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. The MA6 vehicle lifted off.
Well, the rocket was a rising man, goes out ace. Everyone was hoping that he'd go into space. As he rose higher into the sky, the clouds opened up to let John go by. Johnny Glenn. Nobody can. Everybody said he was a traveling man. He orbited twice, then once again. He's our #1 Johnny Glenn, Johnny Glenn. What a man. Hey, Johnny Glenn. What a man. Johnny Glenn, what a man. Yes, Johnny Glenn, he's a mighty man.
Stage of flight.
MA6 vehicle is climbing nicely, has passed through the area of maximum dynamic pressures. Pilot John Glenn is reporting all systems go. He is giving routine reports, reading off his instruments.
And that's about it. As Alistair pointed out, heavensabove.com is a great source of information for all things astronomical. It's not just satellite and space station tracks. They keep track of, well, just about anything, comets, upcoming events, etc. Great site. Our next What's Up is on Wednesday, March the 2nd. Our next regular meeting of the RASC Edmonton is on the 14th. We'd love to have you join us. And Alistair does his introduction to stargazing. The next session is on Wednesday, February 23rd. All these times are at 7:30 p.m. Mountain Time. And the links, the Zoom links are all on our website at edmontonrasc.com. With that, I'll say thank you. And are there any questions?
Jeff, what were they trying to prove by sending the old guy up to space?
It was an experiment to test the effects of space travel on an elderly person. Because as I said in my notes here that Glenn noted that what happens to astronauts in space, that they lose bone mass and they lose muscle mass. The same thing happens as you get older. So his idea was, I wonder if the same thing would happen to someone who's old, who's already had the problem with losing the bone mass and the muscle mass, et cetera, et cetera. So, and it was a way to get him back into space again, because he really did want to, another shot.
And PR.
Gagarin, and PR, yeah.
It bought a lot of PR.
It bought a lot of PR, yeah. And actually, Bill Clinton, who was president at the time, he actually went to the launch. He was the first president to go to a launch since Richard Nixon went to watch the launch of Apollo 12, and Apollo 12 was hit by lightning on the way up. So it was considered bad luck for a president to go to watch a launch. So Clinton saw that one. I think the next one was Trump for the first Dragon flight, but he just probably went there because he could get himself on TV again.
Thank you.
You're welcome. Let's see, what do we got for chats? I didn't actually really look at them here. Oh, we'll tackle them at the end of the segment. Okay.
Yeah, that's.
Oh, so we've answered all that?
Yep.
Okay, good. All right. Anything else? Okay. Well, this
I
is
got a question.
okay.
You said the ecliptic was dropping down. Would it not be coming up with the lengthening of the seasons?
It's relating to the tilt of the Earth and as it goes around the sun. The ecliptic is going to be very high in the evening sky throughout the spring, but it's also very low in the sky in the morning. And it just reverses itself as it goes around, as we go around the sun. The ecliptic just changes from month to month.
It's not easy to describe hand waving. It's a real three-dimensional thing. One of the things that's kind of tough to account for is that, well, the ecliptic, which is the sort of the flat playing field record player of the solar system, like that never changes. It's the Earth's tilt that on one side it seems to be tilted away and on the other side it's tilted towards. Our tilts never change. It's just the relationship. And it's that sort of, as one, it's sort of low here and high on that side, and then it's in between on each side. And it's just that sort of, I can't do it without full props, but yeah, it ends up being that that tilt, like in summer where the sun goes really high, we're exactly opposite in winter, and that's why the full moon rides really high in winter, whereas in summer you'll only ever see the moon duck low while the summer sun is up high. And it's that, well, once we've spun the other way around, we're kind of pointing down instead of up, and it's pretty tricky to do without proper props.
I'll see if I can find some diagrams for next month. How about that? Because a picture's worth, well, my physics 30 teacher used to say, a picture's worth 1,000 words. It's also worth a mark on the test. So I'll see if I can find some diagrams to illustrate that.
Yeah, I love the resource Guyotwell Astronomical Companion. It's an oversized book, and it's been updated with nice computer graphics now, but before, the version I've got is all hand drawn, and you can see this thing of the tilt, and the sky, he sort of superimposes the sky on it, and that does sort of help.
Yeah, I've got I bought the latest, the 4th edition of the Backyard Astronomer's Guide, and I'll see if I can extract something out of there. And because I think he has pictures of that too in there, or maybe I'm thinking of Night Watch. I can't remember.
Yeah, and actually, Jeff, I don't know whether you might want to do it or I can do it. Specifically, as we head into sort of late February and into March, when the evening ecliptic is really steep,
Yep.
like you will always see the crescent moon. I can't quite do it here. There we go. In the evening, it's always very much like this in spring.
Yep.
And in fall, because the ecliptic is this way, and so the planet's path goes right, essentially think of it as slicing the moon in half. But in fall, when we hit summer and the ecliptic is really low, the whole tilt has changed, then here we go. The late summer crescent moon is very low and comes across this way, and is all and the tip to bottom is tilted very sharply this way. But in spring, it's almost all the way over, and you'll never see a spring crescent like this. So there's an old farmer's tale that says, oh, when you see the moon like this, it can't hold water, so it's wetter in these months. And when the moon is like this, you think of it as holding water. So it does, and it's like it's got nothing to do with rain. It's just simply that's the angle of the ecliptic, and that crescent moon is always like that in spring in the evening, always like that in late summer and into early fall.
Yeah, in springtime you'll see some very, very young crescent moons because the ecliptic is so high. I mean, even a day after new, it's quite high up in the sky in the springtime.
Thank you.
Yeah, you might be able to do it nicely, Jeff, with the way you animate your starry night there.
Yeah, I could do that too. I'll look at that.
Evening hours.
Yeah, let's see if we can do that right now. Let's set the date for maybe the 4th.
Oh, and there's another question. Anything for future presentations about the James Webb Telescope?
This really isn't.
You'll have to wait 50 years.
Yeah, or 5. If you want to learn about the James Webb, there's a lot of other RASC centers have put up presentations on that, and we had one a few months ago. I think it was either in October or November. Had a fellow that actually worked on the web, did a presentation. So there's information there, and all our regular meetings are on our YouTube channel. So if you just go to YouTube and type in RASC Edmonton, all our videos are there. So you can look at that and watch that, I suppose.
Yeah, while you do that, I'll go and look for it, and then I'll post it on the chat.
Oh, okay. All right. I am trying to find the moon here. Okay.
I've never met you personally, Jeff, but I always thought about 5'10".
Oh, no, I'm a bit bigger. Okay, so I brought up a crescent moon. So I'm just gonna see if I can share this here. Go back to okay, can you see the Starry Night program there? You can see the moon. This is February 4th, this month. And you can see, as Alistair says, the moon is holding water, I guess you could say. So if we go, let's see here, center that. Let's go to June. It'll have to go back a few days here. And make it a little later because it is June. Okay, so this is the moon in June, and as you can see, it's not laying on its side as much as it was in February. And if we go to August, it's below the horizon. So let's make it, no, that's not going to work. Let me just look at a calendar and see when it's new in August. 31st, okay. Change the time. Change the time. There we go. Okay, so this is the crescent moon in August. August 31st, and like you said, like Alistair says, it's almost standing straight up. It's not laying on its back, and that's an effect of the ecliptic. So, but I'll put something together for next month.
I just wanted to make a comment in your thing on John Glenn there with the song, he's a hero and all this, da-da-da-da. A lot of the engineers on the Mercury program were Canadian, like they had been laid off from the Avro Aero. They went to the States. And so it was a lot of Canadians that put him up there.
Mm-hmm.
Absolutely, yes. Chris Gaynor wrote a pretty good book. It's called Arrows to the Moon, and it's about the Canadians that went after the Arrow was canceled, they went down to the States and worked for NASA, and provided a lot of brain power to get not just Mercury, but Gemini and Apollo as well. So I've got it in my bookcase somewhere.
Wait a minute. Yeah, so September 13. So I'll get the link here shortly. Zoom. There we go. So that's the presentation on the James Webb Space Telescope at our September meeting.
Okay. I saw various pre-launch presentations, including Edmonton, about what's new happening based on what you said, 5 to 50 years. Assuming because it's now confident. I don't understand the question. Sorry. I just picked these historical events that are anniversary years that are either a anniversary /5, like 5, 10, 15, 20, 25, you know. So like I say, in 2022, it's any year. It's something that happened in a year that ends in a 2 or a 7. So, but I don't understand the question here.
Yeah, perhaps part of it is nothing new is happening because the last 3 weeks or so, it's just been slowly unfolding and gearing up. So like I think the first picture, the first light picture is not going to be for another like 4 or 5 months or something like that, because they've got to do all the little engineering tests and align the mirrors and all sorts. So it's not just like, oh, send it up into space and take a picture with the camera. It's a lot more complex a machine than a standard camera. So
Yeah,
it's going to
there's
take
a lot
while.
of commissioning to be done.
Yeah.
Although I did see one picture posted when it was launched, and it was a joke picture. Someone said it's the first picture from the Webb Space Telescope, and it was a backwards red cover that said "Remove before flight." So,
Oh yeah.
Yeah.
Yeah, and the I remember at it's called Stellafane, a telescope making convention in Vermont, and somebody had a small scale version of the instrument that was called the multiple mirror telescope, and it was essentially a telescope with 6 mirrors, and then each one has another mirror to reflect back down and all that. And they essentially proved how complicated it was to have multiple mirrors going on, because you look through the eyepiece and it was just this, you could see there was like 3 distinct images of the same thing all kind of overlapping. It's like not ready.
Yeah, they're going to have to, get all the mirrors aligned. Yeah, it'll be a while before we see any photos coming back.
Yeah, in comparison, the Hubble was quite simple. One primary, one secondary, and then the sensor array.
Yeah. That remove before flight kind of reminds me of a story. I can't remember where I was, but it was a photographing rich event. I can't remember what it was. It was like 20 or 30 years ago. And there was this guy snapping pictures like crazy. And I looked at him and I said, "Oh, that's not a SRL camera, single lens reflex camera." He says, "No." I looked through a viewfinder. And so I kind of reached over and I took the lens cap off his camera, because he had a lens cap over his main lens, the part, of course, that takes the picture, and he was just looking through a viewfinder, and so he wasted a roll of film on nothing. So, but I'm sure they've thought of that with Webb. I'm sure they took the lens covers off.
I'm really amazed about Webb. They talk about cooling off. It takes 2 months for it to cool off. That just throws me. I just can't think of that.
You have to remember that half of it, or its back end, is sitting in broad daylight 24 hours a day. So yeah, the front half, or the side facing the sun, gets it's hotter than the plains of Africa. in terms of how much heat energy it's getting from that. So that's why it's got this big shield on one side and then it's sitting on the other. And then the other thing that's very important with the Webb is that it works in the infrared. And so anything that's warm glows, and it glows bright. So for example, if we turned out all the lights here and these cameras were infrared, we emit infrared light all the time. We even emit very weak radio. And so the telescope itself, just all the parts, that anything that has heat will emit light, infrared light. So they've got to make sure it can cool off and cool off and cool off so that you don't get any signal from the instrument itself. And so it is surprising. It takes a long time for it to cool down because I mean, we all know if we step outside at nighttime at -40, it doesn't take long to cool down. But for an infrared kind of thing, you want the temperature to be, just a few degrees above absolute zero. So that does take a while, and especially if you've got the back end is being beaten with sunlight.
Yeah, even a standard telescope, like an amateur telescope, needs to cool down. If you take it from a warm house into a cold evening, you got to let the mirror or the lens settle down. So you more so with an infrared scope out in space. So. Okay.
And I'm pretty sure they don't want a test image to get leaked out as being, oh, this is what it's capable of doing, because everybody will misread what it means.
Mm-hmm. Yeah. Okay. Well, this was a pretty good evening. We didn't have anybody try and crash us this time, so that's great. So if there's nothing else, I will say goodnight. Thank you to all of you. Thank you for Alistair for your input as always. And don't forget about our next RESC meeting on the 14th. Join us. I can't remember what the topic was. Anyway. All right. So I will say good night. Thank you very much.
Thanks, Jeff.
Yeah, thank you. Thank you.